Here's the latest innovation in my skid that I hope you'll appreciate. One thing that's always drove me crazy about skids is the bolts underneath. They all have the motor mounting bolts on the bottom, right where they get scratched and they get hung up, and it doesn't make for a smooth transition. So I always hated the bolts on the bottom. And the very first skid I ever made was for a Capra, and it was machined out of a plate of Delrin. And I had this groove right here where I had a motor adapter that sat into that groove. So you would mount your motor to the adapter, and then you would mount the adapter to the skid, and then on the bottom there wouldn't be any bolts showing. I like the concept, but I eventually moved way far away from the Capra design. I went through a whole bunch of different iterations, which you can watch in this video here, where I kind of talk about the progression of my thinking on skid design, and that gets us to where we are today. On this channel, we look at the science behind our grown-up toys. I always thought skids were pretty uninspired. It's basically a 2D plate, and you use these threaded rods to hold your rod ends in place. They rattle back and forth. Certainly no disrespect intended to people who design skids, but these were always very simple, 2D, flat, not very creative, and I try to do better. So you can see all my skids are quite a bit more complicated. The latest version of my skid, I wanted to do one big thing, and that is eliminate the screws on the bottom. And I'll show you how I did that. The second thing I wanted to do was to protect the motor better. On my current skid, the motor sits just slightly out in front of the skid like this, and I had to make this little cutout, and the motor's right here, and the motor can get touched right here by rocks that stick up. So I wanted to make it a little better. I wanted the motor to be sunk in. That's why I switched to a yellow jacket motor, which is smaller. And the yellow jacket motor fits behind the leading edge of the skid. So I've got some better protection now against the motor. The new skid here also curves up more than the old one. So I've got motor protection, but also better lead-in for sliding over objects. But the part that is most interesting, I think, is how the transmission will attach to the skid. It will require some modifications of my deluxe portal transmission, but I'll show you how I did it. Also, as a side note, quite a bit of play. It's time for some new bearings, possibly some new axles. This transmission's been run a lot. It still works perfectly, but probably best not to have that much play. But I digress. What I'm going to do is take advantage of these existing mounting holes to mount to the skid. So let me take it apart first. I always run the standard version portal transmission that's completely covered in aluminum rather than the ultralight, which is 2 carbon plates. That's because I like my gears protected from rocks and debris. And you absolutely should always run grease on your gears. I know there will be people who say you don't have to run grease on your gears and you don't have to do anything, but metal on metal gears are absolutely always designed with the intent that they're run with grease. RC crawlers have pretty low loads and low mass, so it's not absolutely essential, but I always grease my gears to reduce friction and to reduce wear and extend the life of the gears. And if you're running in a closed transmission, that prevents dirt and dust from getting stuck to the grease and then ground up in your gears. So I prefer to run the closed transmission housing, which is only 6 or 7 grams heavier, I think, and then I always grease my gears. So what I'm going to do is drill and tap these 2 holes all the way through so that I have mounting points on the back side as well as the front side. If you have the ultralight transmission, you will already have these holes on the back side. These are 3mm fasteners, and the thread pitch on a 3mm fastener is 0.5. So if you simply subtract 0.5 from 3, that gives you the perfect drill bit size, which is 2.5. And you can see 2.5 Just barely fits in these threads absolutely perfectly. Now, after my lecture on grease on gears, you're probably asking, why don't I use lubrication on the drill bit? That would be the proper way to drill a hole, but I find that with a good drill bit in aluminum, it's not really necessary to lubricate the bit. The reason you lubricate your bit is to make it last longer and to make a smoother cut. I'm not drilling millions of holes, so I'm not really concerned about the life of my bit. And also the oil just makes a mess. So I usually drill aluminum dry, and I'm sure some of you are cringing. Another trick that I really like is these free Trex decking samples from the hardware store. They'll give you all you want, and they make great backing plates for drilling. I am wearing safety glasses. You might also be cringing that I don't have the part pinched in a vise. That would be the smart way to do it to protect it better. But it's a pretty simple operation, so I'm just doing it by hand. I actually prefer, on a small project like this, to tap it when I'm holding it in my hand, because then you have a little bit of give on the tap and the bit, and you're less likely to break your tap because you've got a little bit of give. There we go, all set. Now let's do a little test fit. I don't love that the bolts are going in on chamfers, but if we're careful, we shouldn't have any trouble getting the bolt started. Yeah, that goes in just fine. All right. Double check this side. Yeah, that's no problem. Beautiful. All right, we'll put it back together. Purple Loctite is appropriate for this application. I have a whole video right here on selecting the correct Loctites. It's 17 minutes of lots of boring Loctite talk, but in the end, you will know the proper Loctites to use. Now, I do not put threaded brass inserts in my skids. I think it's largely unnecessary. The skids are pretty cheap to print, and if you strip out a hole, you can always get a new skid. Threaded inserts are designed for things that are taken apart frequently, and I really don't take apart my skid that many times, 4 or 5 times, and then I probably get a new skid. But putting in a brass insert takes up more space and more diameter around your bolt holes, so I never put them in. I do, however, always clean up my holes because they've almost always got some printing support or debris in them. So if you're getting your own skids printed like I do, clean them up. Then I always do just a few threads to get it started. Just 4 or 5 rotations. So I've got to start. And then if you're using good quality printed material, you won't need threaded inserts. These will hold just fine. At least that's my experience. If you've got heavy hands and you torque things down tight, you might strip these more often and you might want threaded inserts, but I never use them personally. All right, now comes hopefully the cool part. All right, now let's see if I reverse engineered this correctly. Fits quite nice. Now we need to front side needs to be longer. Probably 14. Let's try that. Oh yeah, seems to be working. All right, so I'll give that a little bit of a tighten. Tighten these. Nice. I think this is perfect. All right. So what I did was I used the existing mounting holes and I put one screw in the front and two screws in the back. And yeah, I do have these holes kind of hanging off the back here, which I don't love. It's not that clean, but it's on the back side. It's certainly not going to hurt anything. And if you look at the bottom of the skid now, no screw holes. Nice. Nice. Now we'll put it back in the rig and see how it goes.